Okay, so let's start out by looking at this simultaneous puzzle. It's a good introduction to what we're going to learn today. So we want to try and find out how much each plum weighs and how much each orange weighs. If we were to just look at this top puzzle, so this top weighing scale with 2 oranges and a plum to be 240, we wouldn't actually be able to solve that, would we? Because they could be all sorts. These could both of the oranges could be 100 and the plum could be 40. Both of the oranges could be 20 and the plum could be 200. We could have almost an unlimited amount of solutions to this, especially if we went into decimal numbers. To be able to solve this, we'd need a second kind of equation or a puzzle or something, whatever you want to call it. We're going to be moving on to equations, but in this case just a puzzle. We need a second one with the same plums and the same oranges to try and figure this out. Well, what do we know about this? We've got 2 oranges and a plum, 2 oranges, 2 plums. The difference between what fruits we have is just 1 plum. The difference is a plum. Let me get a pen. So the difference is 1 plum. And the difference between the weights is 40. And we're going to assume that means grams, 40 grams probably. So that must mean that 1 plum weighs 40. I'm going to call them grams. So then we can go back to either of the puzzles. I'll show that it works in both. And if we use the fact that we've figured out that the plum is 40, we can find out what an orange is. So if a plum is 40 and we took the plum off, that would take 40 off of this to make it 200. So the oranges would be 100 each. Let's just double check it works with this bottom one. We'd have 2 plums. So that would be 80. If we were to take them out, we'd take 80 off this as well. And 2 oranges, adding up to make 200, where we divide by 2, so there'd be 100 each. So we've shown it works in both of them. And that's the really key thing in these simultaneous equations and simultaneous puzzles, is the answer has to be the same in both of them. And I'll go into that a little bit more detail when we get into a later problem. But this is just one for you to have a quick go at, so pause it. I'm going to reveal the answer very shortly. Okay, so if you haven't done it, if you've carried on the video and you've not paused it and had a go, please pause now. I'm going to show the answer in 3, 2, 1. So hopefully you got that the green was 6 and the triangle was 2. You'd have known that both of the triangles were the same. The differences were 2 squares. So the difference would have been 2 squares. The difference was 12. So 2 squares means 12. A square is 6, and we work backwards from there. This is a really common one. Ignore that one at the top. I've just rewritten it a little bit. This is kind of a food order. And this is my favourite way of kind of thinking of these problems, is we have 2 cups of tea and a cookie is £2. 2 cups of tea and 3 cookies is £2.80. Well, someone says, how much do I owe you for the cup of tea? And you'd be like, ugh. So you need to figure out what someone owes you for the cup of tea. We want to find out how much the tea costs, how much the cookies cost. Well, the amount of cups of tea we've bought are the same. So the only thing changing the price is the amount of cookies we bought. So the difference we bought is 2 cookies. In fact, if you want to have a go at this one, please do. Because I've not got a second one for you, so if you want to have a go at this one and just replay the video and check you've got the same as me. Well, the difference we've got is 2 cookies. These guys here. And the difference in the price is 80p. So that must mean that 1 cookie equals to 40p. So we can go back to either of these. I would always just double check both to start with until you kind of get confident that the fact that it always works. I always go back to the easiest one. So I think this one's going to be less work. Well, if I take this cookie out, that's minus 40p. So the new price would be £1.60 for these 2 cups of tea. So a cup of tea would equal £1.60 divided by 2, which is 80p. So we're actually going to look at it. You very commonly see it in terms of algebra. And we can call them simultaneous equations or a system of equations. And these two equations will have the same solutions. So if we just look at the top one, 2x plus 3y equals 12, we could have a load of different solutions for that. We could have x equals 4, and then y equals 4 over 3. We could have x equals 1. Oh, I'm trying to think of one that doesn't give us horrible fractions. Anyway, you can think of that. You can find loads of different ones, but then it needs to work for the second one as well. So there's actually only going to be one unique solution that fits them both. Just like when we kind of took away the ones that were the same and find the difference, we're going to do the same here. So they've written this out in a bit of a weird way for me. I like to rewrite it with my largest amount on top. So you can see, hopefully, that all I've done is just flipped these around, and I've put my biggest amount on top because it leaves me, I won't have any negative numbers that way. We've got 3y in both of them. So what I can do is I can take these equations away from each other. That's all we were doing on the last examples with the teas and coffees and the fruits and the blocks. We were taking them away from each other. So when I do 4x take away 2x, I get 2x. When I do 3y take away 3y, I get 0, and that is the whole point of this. And when I get 18 take away 12, I get 6. We could also look at it in the way, well, what's the difference between these two equations? 2x is the difference, and what's the difference? 6. Well, there we go. We've just written that out, but in algebra. So then x must equal to 3. And then let's go back into any of our equations. I'm going to go back into this one, just because it seems a bit simpler. So substitute in x equals 3 back in. So 2 lots of 3 plus 3y equals to 12. Well, 2 lots of 3 is 6. I'm going to take that 6 from both sides. 3y equals to 6, so y equals to 2. So that would be my solution, my set of solutions. And always just double check that it works. So let's do that. 4 times by 3 is 12, plus 3 times by 2, 6. 12 plus 6 is 18. It definitely works. So, have a go, please. Pause the video, and I'm going to display the solution in a second. I'll do it in 3 seconds. 3, 2, 1. Okay, hopefully you've had a quick go at that one. I'm going to go through it fully, but you can always do a little quick skip ahead if you got that right. So I would take these away from each other. In fact, I'd probably write it out again. So 5a plus 6b equals to 42. Write my largest one on top first, because otherwise I'll just get negative. You still get the right answer in the end, but it's just a bit more work. So let's take these away. That gives us 0. 4b, and that gets us 8. So b equals to 2. We can see we've got that. And I'm going to put b equals to 2 back into here. So instead of 2b, that's going to be 4. So 5a plus 4 equals to 34. 5a equals to 30. And a equals to 6. Spot on. Okay, that's not an example we want to do yet. I'm going to flick to this set of slides here. So, what do you notice that's different between these two? Hopefully you've spotted that, well, they both have the same kind of, the fancy word for this is called coefficient, which means the number before the letter. So they both have a 3. And they both have a 2. But what do we spot slightly different about the second one? Well, the second one has a minus sign here. So if we were to take these away from each other, should we see what happens when we do that? So 4g take away g is 3g, minus 2h, take away 2h, well that gives me minus 4h. What's the problem there? Well, the problem is we haven't eliminated, this is called elimination process, this method. We haven't eliminated anything. Do you reckon you can think what we might need to do instead? Well, if we add these, if we do minus 2h add 2h, that gets us 0. So that's going to eliminate them. So how about I add all of these together? So 5g equals to 20. So g equals to 4. And then when I substitute this back in, I generally like to pick the one that isn't negative. It just makes it a little bit easier. So I'm going to do this one here. So, oh no, I didn't want to do that. Well, what did I have? I had g equals to 4. So I'm going to do that. 4 plus 2h equals to 8. So 2h equals to 4 and h equals to 2. We can see we got them answers there. And then this one, well, this is our one where we have the same sign. And a good little thing to remember is same sign subtract. So if they're the same sign, both positive 3's, we subtract. And if one's positive and one's negative, opposite sign add. So that can be something for your notes. Same sign subtract is easy to remember, and then if they're not the same sign, you do the opposite of subtraction, which is addition. I'll go through this one again quickly. Well, this one quickly. If I subtract these, 3p equals to 15 take away minus 3. So they can get tricky with your signs. Remember, when we take away a minus, that turns into a plus. So that equals to 18. So p equals to 6. And then let's go into this one, because I won't have to times 4 by 6, even though it's not too difficult. 6 plus 3q equals to minus 3. Well, I want to take away 6 from both sides here. So 3q equals to minus 9. Q equals to minus 3. So it's very possible to get negative answers here, and it's quite common that you do. Okay, have a go at these two for me, please. Remember, same sign, subtract. Okay, so I'm going to pop up the answers quickly for you here. You can just double check that. I've got one thing to do after I go through these two, so stick around for that. Okay, so these are the same sign. So I'm going to subtract. Probably going to write the bigger number on top actually, so I'm going to do 9x minus 2y equals to 12 and 5x minus 2y equals to 4. These are both minus 2's, aren't they? So we are going to same sign subtract, triple S. That gets me 4x minus 2y subtract minus 2y. The minus subtract minus 2y turns into a positive, which then cancels to be 0. So 4x equals 8, x equals to 2, and then substitute it in. Well, I'm going to pick this one down here because it's going to be smaller numbers. 5 times by 2 is 10. 10 subtract 2y is 4. So we can do the whole balancing of adding 2y to that side. I'm going to move up here, taking away 4, so then y equals to 3. And then this one, bit of a sneaky one. There's a bit of a ghost plus sign there, isn't there? So these are different signs, so we want to add them together. 3y plus minus 3, 3u plus minus 3u gives me 0. 4w plus w equals to 5w. And 32 plus minus 7 gives me 25. So it's working a lot of your maths number skills. So w equals to 5. And let's plug it into the one that hasn't got negative numbers. So 3u plus 4w, which is 20, equals to 32. So 3u equals to 12, u equals to 4. Okay, bit of a game. I want you to play along with me. This is what we would have played in class, but I can't hear your responses, but I'm just going to trust. All you wanted to do is to say whether we're going to add or subtract them to eliminate. So this first one I'll do it for you, because that's what I would have done. I would subtract these because they're the same sign. Same sign, subtract. So I would subtract these ones because we both got a positive 2p. How about this one? Well, we've both got 1u here, but one of them's negative, one of them's positive. So I would add them together. How about this one? Well done if you said subtract, because we've got negative 3 on both of them. They're both the same sign. How about this one? Well done if you said subtract. Both positive 2s. Just going to pause for a second. If I can get this up. Okay, I am back. How about this one? Well done if you said add, because this is minus 3p and that's plus 3p. Same number, 3, but different signs. How about this one? Well done if we said add again. This is minus 4. This is positive 4x. How about this one? Tricky. Well done if you said subtract. They've written it in the opposite way this time. But we've still got a minus b and a minus b. Same sign. So we subtract them. You may just want to rewrite that one out again if you were to answer this question properly, to line up your a's and line up your b's. I'd write that as 2a minus b. And then final one. This would be an add, because we've got a minus 2c and then a positive 2c. And we will not bother with them ones until another lesson. Okay, that's it from me. So there'll be a couple questions linking to all stuff like this. Hopefully this has given you some confidence to have a go at them.